So in the previous video, I had told you that we'll be using a new package for graph theory. It is called as NetworkX. So what I'm going to do is I'll be importing that. So I'll give import NetworkX. So now this package NetworkX has got loaded. Now what I'm going to do is we'll be first aiming at creating a graph G. So what I'll do is G is equal to NetworkX dot graph and two brackets like this. So this says that the graph G has got created. Now once the graph G has got created, it does not imply that there are nodes and edges. We have to add them one by one. So what I'm going to do now is I'll add nodes. So G dot add underscore node. Please note all these commands we'll be using all these commands very frequently from now onwards. G dot underscore add node, and in bracket I say 1. This means that node 1 has got created. I'll go ahead. Now 1 has got created. I'll do the same for the rest. G dot add node, say 2. I've added node 2. Next, G dot add node, say 3. I've added 3 nodes. Now let me do a few more. G dot add node, say 4, and then G dot add node, say 5. Yes, so I've added 5 nodes here. Now if you want to see the list of all the nodes which are added, what I'm going to do is G dot nodes and then just these brackets will give you this one, node view 1, 2, 3, 4, 5. These are the nodes we have added now. Now we have added nodes. Now what remains is to add edges. So what we're going to do, the command for that, yes, you must be guessing it rightly, G dot add underscore edge. This adds edge between the vertices which you have given already and which you're going to select now within this bracket. You see here, U of edge, V of edge. Do you see this? So it says that you have to give vertices, you have to mention vertices in this bracket. Now like this. So what I'm going to do now, enter, yes. So this has added the edge 1, 2. So between 1 and 2, these vertices, an edge has got added. Just like how we added nodes, we'll be adding vertices now. So G dot add edge. Let me add one more, 2, 3. G dot add edge 3, 4. G dot add edge 4, 5. Now I have added say 4 edges here. Just like how we displayed the nodes, we can display the edges too. So it will be G dot edges and same like that. Yeah, do you see something? Edge view 1, 2, 2, 3, 3, 4 and 4, 5. It displays all the edges that I have added till now. Now let me show you something like this. G dot add edge. See, once you have completed adding your edge, it does not mean you cannot add any more edges. You can always do that. But what is the best part here is if I give something like G dot add edge, say 1, 6. Do you see that vertex 6 or node 6 I have not added here? G dot add node 6 is not there. But still, when I give this command G dot add edge 1, 6, the node gets automatically created. Which one? 6. The node 6 gets automatically created and then creates this edge 1, 6. So let us do that. Now let us just check G dot nodes. See, do you see 6 here? So the nodes are 1, 2, 3, 4, 5, 6. The node 6 has just now got created. Now let us check the edges. Do you see 6 has got added here? So 1, 2, 1, 6, 2, 3, 4, 5, 2, 3, 3, 4 and 4, 5. So these are the edges in our graph. So now every time I have to use NetworkX dot graph, if you remember, this was the initial command which how we started. Do you see this input line 28? So each time I have to do this, it becomes difficult for me to type this entire word NetworkX. So what I'm going to do now, NetworkX graph like this, what I'm going to do is, so each time we have to use this NetworkX like this, G is equal to NetworkX dot graph. You see, I had already used it before in the first line here. Do you see that I have to type NetworkX again and again, right? So what I'm going to do instead of that is I'll directly import NetworkX as NX. So I'll be using NetworkX as NX from now. It's a short form and it becomes easier for us that way. So now if I have to create a new graph, let's say H is equal to NX dot graph. I need not type NetworkX again. So H is equal to NX dot graph. This graph H has got created. So do you see the importance and significance of NX? So from now on, instead of NetworkX, typing NetworkX, we'll just say NX. So we have created the graph G and H. Let me just go back to G. Let me show you what are the nodes. G dot nodes. Nodes in G are 1, 2, 3, 4, 5, 6 and G dot edges. So this will show you all the edges till now. 1, 2, 1, 6, 2, 3, 3, 4, 4, 5. So these are the edges. Please cross check. Now you have the graph there, but you want to visualize it, right? You want to see the actual graph. So at this point, what are we going to do? We are going to use another new library called the matplotlib. It will be clear with you as we use it. So what am I going to do? We are going to use that package as by importing it. So import matplotlib. So did you see this? Import matplotlib. But I'm going to use only pyplot. This is the sub package what I'm going to use. So matplotlib.pyplot, this is very relevant to us. It becomes difficult to type this entire phrase matplotlib.pyplot every time, and hence I'll import this as PLT. You see, PLT is much easier than typing this entire thing. So now this package has got imported. So what are we going to do? NX dot NetworkX dot. Now we are going to draw the graph. So you're going to give the command draw. What are you going to draw? G, the graph. Do you see the graph here? But we don't know which vertex is 1, which vertex is 2 and so on. So what are we going to do? The immediate need for us is to label the vertices, right? So we're going to label the vertices using the command nx.draw in brackets G, comma, you want labels, right? So G with labels, with underscore labels equals 1. So what does this mean? It's going to draw G with labels. This command is true. Why? I have given 1 here. So this becomes true and the graph gets labels. Do you see this? 1, 6, 2, 3, 4, 5. So we have now obtained our graph with labels. So now as a practice, we're just going to create another beautiful graph. So what we have to do is NetworkX has already got imported, so we need not import it again. So we can directly start adding our edges and creating the graph. So let me just create a new graph. Before that, you see we have all these commands here. So I just want to remove all of them and have a new screen. What I'm going to do is I'll give this command clear. With this command, everything gets cleared and you get your new input line, start typing your commands here. So you see we have already imported NetworkX. We need not do it again. So what I'm going to do is, let me create a new graph, say Z. Z equals NX. We had imported it as NetworkX. NX dot graph like this. So now the graph has got created. What do we have to do next? We have to add edges and nodes. So what I'm going to do is Z dot add node as 1, and then Z dot add node 2, and then Z dot add node 3. Let us take a few more. Z dot add node 4, and then Z dot add node, say 5, and then Z dot add node, the last one, 6. So we have added 6 vertices. Let us just list them all. Z dot nodes in brackets. So this is giving all our nodes here. Now let us add some edges. Z dot add edge, say 1, 2. Again Z dot add edge, say 2, 3. For simplicity, you can always use your up arrow and get the command like this, and then go back to your bracket and change what you had to write there. So 1, 2, 2, 3 I have given. Then let me give 2, 4, and then again 2, 5. So do you observe what I'm doing? I'm just giving all edges as connected to 2. So 2, 6. Yes. So let me check all the edges now. G dot edges, brackets. Yeah, 1, 2, 2, 3, 2, 4, 2, 5, 2, 6. Do you see all the edges and the nodes here? So now let me draw the graph. We have already imported matplotlib, so we need not do it again. So what I'm going to do is nx.draw. This was the command to draw graph. Z, whatever you have labeled your graph as, you need to give that inside here. nx.draw Z. Do you see something, this beautiful graph here? But again, as you remember, we need to add labels in case we need the labeled vertices. So what I'm going to do is nx.draw. It's all small, it's case sensitive. Please note that nx.draw Z with labels equals 1. So this is true labels. It means that I'm going to give my labels now. Let us see the graph. Yes. So 2, this vertex 2 is connected to 1, 3, 4, 5 and 6. Did you see this beautiful graph? So you can just play around like this and create more graphs by randomly adding nodes and vertices. So you see we have got this graph here, but don't you feel that this red color is quite boring to see always? So let us change the node color to something else. How do we do that? Yes, so you give nx.draw as earlier, the graph was Z, and then with labels as true, and then here what you have to do is node underscore color. Node underscore color equals, in quotes you give B. B stands for blue. Let us see. Did you see that we've got blue color nodes here? Isn't this very interesting? Now let me change the node color, say to G, green. Well, we've got green color nodes here. Now please don't give any random color and try and you'll end up getting an error. You see, you have to give some standard colors and you'll see these beautiful nodes. Now let me clear my screen. Yeah, so now we are going to start with a new topic. What am I going to do now? We will see you every time import your NetworkX as NX and you add edge, you create a graph, you add edge, you add nodes. Don't you think this is a very tedious process. Suppose you want to draw a graph on say 25 or say 100 nodes. Can you manually sit and add all your edges every time? No, it's just impossible. So there are various methods to create the graph. One among them is using the built-in functions which come in with NetworkX. So what is it? You see, we have seen some standard graphs like a complete graph, a path graph, and then a cycle. So we can do that just with a one-line code. So let me import NetworkX as NX. Now I'll start doing it. Let me say K equals NX dot, you see, complete underscore graph, and in brackets you have to now give how many nodes you want it on. Let me just give 5 to begin with. Now your graph K has got created. NX dot draw, if you give in brackets K is your graph. Do you see this graph on 5 nodes here? This complete graph on 5 nodes? Now let me just do another one. Let me say L is equal to NX dot complete graph on, let me say, some 25 nodes. And then let us see, visualize it using NX dot draw and L. Do you see this complicated network here? Isn't this very interesting to just play around using NX dot complete graph, give various number of nodes, and then visualize the graphs? Now let me make your life a little more complicated. Let me say M equals NX dot complete graph in, let me give some 70 nodes, and then NX dot draw M. Do you see the structure here? You're not even able to identify the edges hidden in between. Now what comes to our rescue now is another beautiful feature called layout. What does it do? It helps us segregate the edges properly and visualize them clearly. So now I will give something like this. Position, POS, position is equal to NX dot circular layout. And what is the circular layout of this graph? Okay, my graph is M, not G. Yes. So now I have given this layout called circular. There are several other layouts. We'll be seeing one by one. So position NX dot circular layout M. Now let me see how the graph looks like. NX dot draw and then the graph M comma POS. So the graph looks like this. Yes. Did you see all the nodes are in the circular format towards the end of it like this? See, it becomes difficult if we have to each time use NX.draw as well as NX.circular layout. Well, we have a simplified command NX.draw underscore circular, and in the bracket let me give M. You see, it just came with one command. You need not use two commands. Well, what I want to mention here is the significance of these built-in functions in NetworkX. We'll be seeing more of them. Let us now see another layout. It is NX.draw spring. There is some layout called like spring. Let us see how it looks. Do you see? This is yet another layout or a visual feature of this graph. NX.draw, let me say random. It's just going to give a random look to the graph, and M, we get a random one like this. Now NX.draw, let me say spectral. M. Do you see how the graph is looking? So These are various layouts. We'll be seeing more functions in the next video.